3.7, graphing absolute value of function. If we recall, in previous chapters, we had absolute value in equations, right? Where we had to basically do what? X plus 3 equals 4. The absolute value is the distance, or how far away, units, we are from 0, whether going negatively or positive. It's the actual unit, it's the actual amount, how far we've gone. So if we had this, we know that if we had to send it into one positive and one negative, so it would have been x plus 3 equals 4, and x plus 3 equals negative 4. When we had it in absolute value, in inequalities, we had two different ones, right? We had x plus 3 is greater than 4, which this would have been or, correct? We would have it x plus 3 is greater than 4, or x plus 3 is less than negative 4. If it would have had less than x plus 3 less than 4, it would have been and. Therefore, x plus 3 is less than 4, and x plus 3 is greater than negative 4. Okay. But now we're going to be using it in absolute value functions. Let's go on to the next slide to introduce. Here we have the absolute value functions, a function that contains absolute value expressions. So the parent of value function is going to be f of x equals absolute value of x. Well, we know that this equals y. So in this case, the graph of f of x gives us absolute value is going to be a V shape. And is symmetric about the y-axis. So in a way, think about it as when we had before, we just saw the inequality and in equations. Here we're going to have what? Basically a positive and a negative. And they have a vertex, which the vertex is the point where the graph changes direction. We were going, this way was going positive, but this way is now going the opposite of where's x is going negative, right? And this is going positively. The vertex of where f of x basically means is going to be 0, 0. The domain of f of x is all real numbers. And the range is going to be y is greater than 0. When it's going to be y less than 0 or y given a number, it will be because it's going to be negative. So let's put it to practice in the next slide. Here we're told, remember in 3.6 we were given what? Our Schrenkenden translation. This is the same thing, the only thing is that we are working with absolute value. So the plus k, who remembers the plus k? What type do we have with the plus k? We had a vertical what? Translation. And when it was in the inside with H, remember, I want you guys to memorize it that way. H for horizontal and the K, which you're not going to see horizontal, but it's within. The shift is happening where? When X is being moved by H. This is going to be horizontal. There are different ways that you could work this. Either you could just see it or do a what? Table to plug in numbers. The first thing you want to do is graph each equation, compare the graph f of x equals x. That's the first I'm going to do. Parent, just like the other one, we're going to do what? Graph our parents. And our parent, we said that it was going to be the vertex of f of x. It is what? 0, 0. So this is my line, and this is my parent, which is who? F. Now we're dealing with line G. And it says the absolute value of x. So any number you multiply absolute value of x plus 3. If you do a table, we know the table you're going to have x, g of x, which gives us, I'm going to use -1, 0, and 1. What I'm doing now is going to use substitution. Substitute. What's the absolute value of -1? 1 plus 3, which gives me 4. The absolute value of 0 is 0 plus 3 gives me 3. And the absolute value of 1 is 1 plus 3 gives me 4. Now I have new points, which are what? -1, 4, 0, 3, and 1 and 4. I'm going to do another color here so that we can see it. -1, 4, 1, 2, 3, 4, 0 and 3, and 1 and 4. And this is our G. So what do we have in here? Who is K? Remember, K is our 3. That's how we know it's going to be vertical. So it was a vertical translation 3 units up. Remember that vertical determines is up and down. 3 units up of the graph. What's my domain? D for domain, okay? My domain is what? All real numbers. And my range is y is greater than or equal to 3. That was given. Okay? 2, 3. So here we have who? So 3. So y is going to be greater or than equal to 3. So anything above up here will be a solution. In B, again, we can do what? We can do a table, or you're able to do a mental. This is simple. One that we will get into once where it's not as simple. So I'm going to give you another method. Again, we're going to do what? Our parent. Just because it was given to us and they told us f of x equals the absolute value of x. So we know this is f. I already know that this is going to be a what? Horizontal. Because the h is happening inside, right? So h equals who? Equals 2. Therefore, my line is also going to be what? Horizontal translation with what? Mm-hmm. 2 units to the right. Good. And it's to the 2 units to the right of the graph. So now I'm going to have it here. So this is 1, 2. This is my new line. If you prefer to do points, you're able to, but I just want to show it to you in written forms. This is now our line what? M. What is our domain? Our domain is all real numbers, and our range is what? Y is greater than or equal to 0. Remember, we're at 0. This is basically 2, 0. Now we are in stretches, strengths, and reflectance. So if you recall, previously, our A's. You see our A's here? Let me highlight it instead. Our A is here. So who's A here? It's 2 and this. So what's happening here when A is outside? When A is outside, what's happening here? It's vertical. Correct, vertical. A needs to be inside. It would have been correct, horizontal. So here we have, you could create what? A table, or we're going to do A with the table and B, we'll do it mental. So A here we have, they're going based on our parent. Okay, so the first thing I'm going to do is graph our parent, which they told us the vertex is 0, 0, and anything. It's kind of similar to the other, but here in absolute value we have what? A V shape. So when you guys see V, no, there's an absolute value happening there. This is F. And your table will be X, so we have Q of X. And I use low numbers, 1, I'll start with -1. 0 and 1. Substitution again, the absolute value of -1. 1 times 2 gives me 2. The absolute value of 0 is 0, and 0 times 2 gives me 0. And 1 times absolute value of 1 is 1, and times 2 gives me 2. So my new points are going to be -1, 2, 0, 0, and 1 and 2. This is who? Q. So what happened with Q? In this line. Remember, we multiply A, which A was we're multiplying A to what? Who do we multiplying A to? If you recall that on 3.6, we're multiplying A is what we are multiplying, correct, to the whole function, right? To the whole function. What coordinates are this? Correct, the Y. Okay, so now we know that A equals 2. We established that A equals 2. What else do we have? A vertical stretch. And we have what? Vertical stretch by a factor of 2. And what is our domains? Domains is all real numbers, and our range is Y is greater than or equal to 0. And B, same thing, but now it's negative. That means you automatically, when you see a negative A, you should know that that's going to be an upside down V. Okay, we know that this is our parent. I always like to graph it first. You should too, until you grasp it, and you might need to graph the parent and you'll kind of understand it. So here we have what? -half. If I was to plug in numbers, what's the first point that I have -half? I'm going to use the same numbers of the other, -1. -1, which is absolute 1 and 1, is, I already know it's going to be 0. Okay, I know it's going to be 0, because if I multiply them 0, and I'm going to upside down and it's going to be 0. So I'm just going to do the points of -1, 0, and 1. Same points as before. So absolute value of -1, absolute value of -1 is 1 times -half gives me -half. So I'm going to have -1, it's -half, and 0, 0, we already plugged it in, and 1 times -half gives me 1 over -half. Let me do the point nicer. That means my line is and that is going to be line P. So what happened here? A is half. We know that A is half. It was given in, so it's a vertical what? A vertical shrink by a factor of half with a what? Reflection. It's a reflection because it's negative over the what? X-axis. And my domain is all real numbers, and my range is y is actually less than 0. Why? Because it's negative. Vertex form of an absolute value function. So if you remember that the vertex, the one we did previously, the vertex of f of x, of absolute of f of x, is going to be 0, 0. Now we have an absolute function written in the form of g of x equals a minus h plus k, where a cannot equal 0. If it equals 0, that means that we have the whole absolute value being multiplied to 0. So that's why it cannot be 0. Here the vertex is going to be where h and k is the vertex. So in a way we can understand it will be our horizontal and our vertical. An absolute value can be written in vertex form, and its graph is symmetric about the line x equals h. We're going to work it out on the next page, on the next slide, so we can see. We're going to be graphing line f and g. F of x equals absolute value of x minus h plus k, and g of x equals f times ax. So I already can see that I have here what? Step 1, what I'm going to do is make a table of the values of each of the function. So my first function, f of x equals absolute value of x plus 2 minus 3. I'm going to give, remember that this is the same as y, correct? I'm going to give points -1, 0, and 1. Substitute, what's -1 plus 2? 1, and absolute value of 1 is 1 minus 3 gives me -2. And 0 plus 2 gives me 2. And 2 minus 3 gives me -1. Then finally we have 1 plus 2 gives me 3. And with the absolute value of 3 is 3 minus 3 gives me 0. So I'm going to now do, I have my order pairs there, which are my points. But now what I'm going to do is, I'm going to go for the table for g of x equals absolute value of 2x plus 2 minus 3. Again, I'm going to use the same points, -1, 0, and 1. And this is going to be g of x. -1 times 2 gives me -2 plus 2, 0. 0 minus 3 gives me -3. Correct? Yes. Then we have 0. 0 times 2 is 0 plus 2, 2. And 2 minus 3 will give me -1. And then finally we have 1. 2 times 2 is 2. 2 plus 2 is 4. 4 minus 3 gives me 1. I am now ready to go. I forgot to do a graph. Enter the graph. So by graphing, we already know I'm going to graph f first. So I forgot to enter a graph earlier, so a little too late for that, so we're going to have to do. We're going to have 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4. Inserting my points now, I have negative 1, negative 2, 0, negative 1, and finally 1 and 0. So remember, the absolute value needs to look like a V. Go this way, and that's my vertex, correct? On my second one of G, my second line is negative 1 and negative 3. Then we have 0 and negative 1, and this 1 and so that's our line. Remember that this is for G. Oh, this is G, and this is F. So what can we describe what happened here? Remember, we draw a V-shaped graph for each of the functions. The vertex for line F, which is over here, right? It is right over here, which gives us negative 1 and negative 2. The symmetric is going to be at negative 1. So far we're putting everything together. We know that they told us that G of X is what? Equals FA of X. So we're going to use this as G of X equals F of AX, which is G of X equals F of what? 2X. Correct? So we're going to have a horizontal shrink by a factor of half. Our y-intercept is the same, correct? Which is, in this case, negative 1.